So if we do that, the del x would be minus a over n. So we have b and a, but we obviously need to know n as well. That means how many subintervals we need. So since your question says R4, that's the hint you have. It didn't say anything directly about how many subintervals you need, but this R4 is significant enough. It says that n is 4. Okay, so if we now find it, b is 4, a is 0, and n is 4. So length of each of the subintervals would be 1. Okay, so we start doing that. So the first subinterval would be 0, 1. The second subinterval would be 1, 2. Third one would be 2, 3. And fourth one would be 3, 4. So we have successfully found 4 subintervals because it said 4. So we need to have 4 subintervals. And we have also made sure the length of each of the subinterval is 1, which is also true for all of this. Right? Any question from this before we move on? Any question? No questions at all? Okay. Then we can move for the next step, excuse me, which is using the formula. So what's the formula? Let's do the left Riemann sum first. What's the formula for left Riemann sum? Anyone? Formula for left Riemann sum.
It would be
Yeah.
delta x times, in parentheses, f of all of the left-hand limits, so 0, 1, 2, and 3.
Okay, so 0, 1, 2, oops, sorry. 2, oh gosh. Okay. And 3. Yeah, you're right. Very good. So we know that this estimation is nothing but adding all the smallish rectangles we have. Well, as I said, we don't need to draw all the graphs, we can actually imagine. So if the graph of this function, we can imagine this, as I said, looks like this, we can just imagine 4 rectangles. That's 0, 1, 2, 3. Yeah, 4 rectangles at this point. So what we are doing, we are just estimating the area under this curve by adding the areas of these rectangles, right? Let me just quickly draw the rectangles for you. Now, we're doing the left Riemann sum, right? So it should start from here. I apologize for the bad drawing anyway, but you can clearly imagine what's the case here, right? Oh, we should have more. Oh, okay. So we have to go to 4, right? Yeah. Sorry. So it would look like this. Okay. So it's a bad drawing. I think I should remove this. Yeah, it should look like this. Okay. So all we are doing here is uh, finding the areas of each of those rectangles, and then if we add this, we'll get the area, an estimation, not the exact area, but we'll get an estimation what might be the area under this curve, right? Okay, so if you just forget somehow, not here, maybe someday in future, that how to find the, or what would be the formula, oh my god, I actually forgot. You can actually go back to the drawing board and see that the area of these rectangles are nothing but the height and the width, right? Nothing else. This width is definitely del x, and the height is, as you can see, is the functional value at this point, right? It's the functional value, nothing else. This part is actually the functional value, right? So if you go back to the drawing board, it should still uh, give you, um, or rather, it might refresh your memory that the graph will look like this. So uh, let's keep doing our main calculation. So del x is 1. What's f of 0? Remember, our f of x is 10 square root of x. What's f of 0? Anyone?
Is it 0?
0, yeah. So all we need to do is to replace the value. Oops, someone in the waiting room. Sorry, I couldn't notice. Okay, I can, yeah, he has joined. So all we need to do is to replace this x by these values, right? We just need the functional values at those particular points. So f of 0 is 0. What's f of 1?
Is it 10?
Sorry?
10?
10, exactly, yeah. So 10 times square root of 1, it would be 10. So if we keep doing this, it would be 10 square root of 2 and 10 square root of 3, right? Now all we need to do is to use our calculator, and um, we can write it up to 4 decimals, okay? So if I do that, let me use my calculator and see. Square root of 10.
Could you do it as an exact answer? So, like if you squared everything, including the left side, and then did the like arithmetic and then took the square root of that?
Uh, I didn't understand. How do you square it?
Like to get rid of the square roots?
Yeah, I understand your question, but I can't see any way to square it anyway. How can I square it?
If you square both sides, so you write L4 squared equals everything else squared, you get 100 plus 200 plus 300, and then take the square root of that. Is that possible?
Oh, no, no, no. That's mathematically wrong. Let me show you
Okay.
why. So let's say we have a equals to, um, let's say, square root of 2 plus square root of 3, right? Let's say. So If I square it, it actually gives us this, not 2 plus 3. It gives us 2 plus 3 plus 2 times square root of 2 times square root of 3. Remember the formula for a plus b, the quantity squared,
Oh, gotcha.
right? So you don't
Yeah.
get 2 plus 3, you have additional terms,
Okay.
right? Yeah,
I treated them all separately. That makes sense.
yeah, of course. All right, so has someone figured out the value meanwhile? If you haven't, let me do that. Excuse me. 10 plus 10 plus 10 square root of 2 square root of 2 plus 10 square root of 3. Okay, I have got 41.4626. Is this what you have got as well? 41.4626. Can anyone verify it for me? Because I could do it wrong.
Yeah, that's what I got.
All right, so this should be our left Riemann sum. Okay, this should be our left Riemann sum. Any question from this before we move to the right Riemann sum? Any question? You can see the calculation is pretty easy. It's mostly algebra, but you need to make sure which formula you are using and use it in the exact place, using in its exact place. I mean, since you are doing the left Riemann sum, just make sure you're taking the left end points of the subinterval, right? For the right Riemann sum, take the right end points of the intervals. And if you're doing the midpoint sum, just take the midpoint of each of these subintervals. That means just add this and divide it by 2. Sorry, this is not del x, so you might get confused anyway. Yeah. So that's it. The rest is pretty much algebra, right? All right, so if you don't have any question, we can do the right Riemann sum now. Let's do the right Riemann sum. Okay, so R4, the right Riemann sum, del x. Now again, can anyone tell me the formula? Someone else? I guess someone has already told me the formula for the left Riemann sum. Can someone else tell me now the formula for the right Riemann sum?
Will it be f of 1 plus f of 2 plus f of 3 plus f of 4?
1, 2, exactly, yeah. So we'll be just taking the right endpoints, right? So f of 1 plus f of 2. See the yellowish circle here? We'll be just taking these values, nothing else, plus f of 4. All right, del x is once again 1, and we'll be just replacing our function by these values, right? So f of 1 would be 10, f of 2 would be 10 square root of 2, f of 3 would be 10 square root of 3. Oh, And f of 4 would be 10 square root of 4. And we can actually rewrite it as 10 times 2, right? Because square root of 4 is 2. We can write it as 10 times 2. All right. Now, once again, if I use my calculator, so 10 plus 20 is 30. And we need to add this 2 as well. Let me use my calculator and see. So 30 plus 10 square root of 2 plus 10 square root of 3. I have 61.4626. Once again, can anyone verify it for me?
That's what I got.
Okay, perfect. .4626. All right, so let me show the entire problem on the same screen if I can. Almost. Yeah, okay. So now take a look at this and see if you have any question. You'll definitely see a question like this tomorrow. I'm spoon feeding you the question, okay? You'll definitely see a question like this. Just the function will get changed, nothing else. The idea, the way of calculation, everything will remain the same. You just need to do it for some other functions. I mean, the values will get changed, right? Maybe it will not be for from x equals 0 to 4. Maybe it will be for x equals 2 to 7. You never know, something like that. But the idea is exactly the same. And you can see it shouldn't take more than 5 minutes. If it does take, no worries, you can take even 20 minutes for it. No worries with that. But I'm telling this because it's not that time consuming if you just know how to use the formula, right? Any question from this? No question at all? Okay, so let me give you one for practice, because this session is all about practice, as I said, and I'll give you a smallish one, okay? So your problem would be f of x f of x equals to, let's say, 7 plus 4x squared, okay? And you need to do it for x equals to -1 to x, oh gosh, to x equals to 2. And you have to find the right Riemann sum and the left Riemann sum. Okay. And once again, I'll create the breakout room and I'll give you 5 minutes for it. Let me know if you have any question, okay?
We did was the first thing we did was find delta x, which was 2 minus -1 over 3. And so the answer to that was 1.
Very good, thank you. Okay, so we have del x. Group 2, Brody, Cooper, or Matthew. What's next? We already have the length of the subinterval. Subintervals, I should say. What's next? What should you do next? Group 2. Brody, Cooper, or Matthew?
Can you repeat the question? Sorry. I was looking at my paper.
what's next? We already have the length of the subintervals. What should we do next?
Break it apart into intervals.
Okay, we can do that. So what are the intervals?
-1 to 0, 0 to 1, 1 to 2.
All right, thank you. Yeah. So we
And
have
then-
the subintervals. Now from group 3, Cole or Kimberly.
What we started with was the left. So we just did, I just wrote it out by hand because I had to write everything out, but we just had the delta x times f of -1 plus f of 0 plus f of 1. And I can put down what we got. We just plugged obviously those into the equation. And so what I got was 11 plus 7 plus 11, which was 29.
11 plus 7 plus
Yep.
11.
Yep.
Okay. Okay, let us verify that.
Yeah.
Okay, so first of all, this is the formula we'll be using for the left Riemann sum because these are the left endpoints, right? Okay, now since the function is 7 plus 4x squared, if we plug in -1, it becomes 7 plus 4 times -1 squared, which is 4 times 1. So 7 plus 4 is 11. That's right. Then we have 0. So if you plug in 0 in place of the x, we'll have 7 plus 4 times 0. So it will be 7. And if we plug in 1, like the way we have done it for -1, it's still 11, right? Because 1 squared is 1. So 7 plus 4 is 11. So yeah, you're right. It should be 29. Any question from this? Okay, can someone from each group verify me by giving me a thumbs up or writing in the chat that you have actually the same answer? Can someone from each group, at least one from each group can verify it? I think I have got this answer from group 3. So group 1 and 2, can you verify? Is this what you have got? Is the answer?
We did. Group 1 did.
Okay. Group 2, have you got the same answer?
That's what I got at least.
All right. What do you mean at least? You, because you had to do it in groups, right? So I think I didn't ask it before. Well, it's too late. When I create the group, don't you talk with each other? I mean, share your thoughts. What should we do and all that? That's why I create the groups, right? You need to do it in groups, not separately, not individually. When I'm creating the group, I'm creating it because I want you to interact with each other. It will definitely create more friends. That's one of the major reasons I should say. And the second one is you can share your ideas. One might know how to find the length of the subintervals. The other could help you with the formula and all that. So just talk with each other, okay? Not for this group. I guess you'll not, probably you'll not see Zoom meetings from the fall. So maybe the last for some of you, if you're not going for the second summer session anyway. But that's the reason of creating these breakout rooms anyway. All right, group 4 has only one. I wonder why, but anyway, I guess someone has left the meeting. Anyway, group 4, James, what did you do next for the right Riemann sum? James, can you hear me? I don't think you can hear me. Okay, I'll go back to group one. What should we do now?
Would you plug the would do the right side? Sorry.
So,
And so,
so did you plug in f of 0, f of 1, and f of 2?
yes, and get 41.
41. Okay, we'll verify that. So we have 41. Okay, and it's 1 times f of 0. Excuse me. F of 0 is 7 times 0, so it should be 7. F of 1, we already know it's 11. So you can see if you have already done left Riemann sum, you just, it doesn't matter how many subintervals you have. For the right Riemann sum, you will need just one more, the most right part. Other than that, the rest is already there for the when you calculated left Riemann sum. So that saves time. That saves time. You don't need to do it again and again. It will give you the same result. All you need is, in addition to the left Riemann sum, you will need just this one. Okay. Or if you are doing the right Riemann sum first, you'll just need the leftmost point. Other than that, the rest will be from the rest can be derived from the right Riemann sum, right? So whichever you do first, you can actually use the values in the other one. Okay, f of 2. So 2 squared is 4. So 7 plus 4 times 4, that is 7 plus 16. So it's 23. And if I add this, I get, do I get 41? Or did I do it wrong?
I got 41.
Oh yeah, right, yeah, right. We do get 41, you're right. Yeah. Okay, now once again, can someone from group 2 and 3 verify that you have the same answer?
Yeah, that's what we got. Group 3.
Yeah.
Very good. All right. So you have already done one question. Yeah, I guess at least one really good question for tomorrow's exam. Because in tomorrow's exam, you'll see a question like this, as I said. Okay. So if you know how to do this, you have already got a fair share of the next exam. Okay. All right. Let's do the next problem. Let's see what we have next. So for tomorrow's exam, I guess I have set up a question from the definite integral. I assume I definitely have. Let me cross-check it. Obviously one from the Riemann sum. Yeah, definitely one from the definite integral. Yeah, that's for sure. Okay, so let's do that. Let's do one definite integral. Number 2. And let's say you have from I don't want to make up a problem which might look clumsy, so okay, I think I can take it from this one. Okay. All right, yeah. So from 1 to 2, let's say we have e to the x minus 7. No, let's take it from 0 to 2. 1 to 2 is really small. 0 to 2, e to the x minus 7. Okay, let's try this one. It's a really easy function to work with, to be honest, but let's try this one. Okay, so you'll see a question like this. I mean, when I say it like this, I meant definite integrals. Okay, you'll definitely see a definite integral. So since you're here, let me tell you. So you'll have one indefinite integral, one definite integral, one indefinite, one definite, one Riemann sum. So these three questions are guaranteed. You'll definitely see 3 questions, one of a kind, you know. And you'll have more questions, though, but at least these 3 you can surely find tomorrow. You will. I think I should say you will definitely find tomorrow. Okay. So the good thing is when you are doing the definite integral, eventually you are doing the indefinite part as well, because finding the antiderivative is the same. For indefinite part, you just add a c. For the definite part, we just need to evaluate it at those limiting points, right? Nothing else. So it's less work for the indefinite part. For the definite part, we just need the evaluation because we'll have a precise value. Like this one. Let's try this. So what should we do first? What's the first thing we need to do? Anyone? Excuse me. What's the first thing we need to do?
Should we find the antiderivative or is that not yet?
We can, but okay, let me do it. Yeah. So what's the antiderivative of e to the x? Someone else? E to the x? Anyone?
E to the x.
Exactly. So for e to the x, I guess it's the best function when you're in the calculus course. The e to the x is the best function. The derivative of e to the x is e to the x. The antiderivative of e to the x is also e to the x. Isn't it cool? All right. What's the antiderivative of 7?
7x.
7x. Very good. And we need to evaluate it like this. If it was indefinite integral like this, we would have written e to the x minus 7x plus c. That's it. That would have been the answer. But for this one, we're not yet done. We still have more work to do. Okay, so how to evaluate it? Someone else. What should we do? Am I recording by chance? Yeah, I'm recording. Very good. What should we do? Lexi, can you tell me how to evaluate these enter derivatives at these points. I think I should give this parenthesis anyway. Otherwise, it might look that I'm evaluating -7x only, but that's not the case. I need to evaluate both. Lexi, can you tell me what should you do? Lexi, are you here? I don't think she's here. Okay, yeah, someone else. I guess Matthew was trying to say something.
I was just gonna say plug in 2 for x and then subtract 0 for x.
Okay, so like this, e to the 2 minus 7 times 2,
Yeah,
and then minus e to the 0 7 times 0. Yeah, you're right. So we just need to plug in the upper limit first in place of x, then subtract it, then not subtract it, then subtract the terms by plugging in 0 in place of x, in place of both of these x's, right? So e to the 2, I think we can keep it e to the 2. We don't need to find the decimal unless it's actually mentioned that write the solution up to 4 decimals or something like that. But I think we can keep it e squared. I'll keep it at least for the first time. Then -14, e to the 0 is 1, and 7 times 0 is 0. So I assume the value should be, oops, sorry. It should be e squared minus 15. Any question from this? No question at all? All right. So let's take a break for one last break, and then we'll come back and practice some more problems. Okay, so let's meet at 10:16.
Yeah, we got 5.
Okay, let's try and find it. So we're looking for from 10 to 15 f minus g. So first of all, we can clearly use the sum rule and subdivide the two functions, I would say, not two terms, like this. And we know the values, right? What's from 10 to 15? What's the value from 10 to 15 for the first function? It's 10. What's the second one? From 10 to 15, g of x is 5. So yeah, you're right. The solution for the first problem is 5. Any question from this? Any question from the other 3 groups? I can see the group 4 had only one member. The other didn't really join. Anyway, any question from the other 3 groups? I can't see anything as yet. So I assume you don't have any question. Let's move to the next one, group 2.
We got 4.
4, okay, let's see. So from 10 to 11, we want f minus g. Once again, we'll use the sum rule, 10 to 11 g of x dx, but we may not have, excuse me, the values straight away, do we? From 10 to 11, we have the value for g, but we don't really have the value for f. So we need to find it first, right? So we'll come back to it. Let us first find the value for 10 to 11. So we know from 10 to 15, f can be written as 10 to 11 plus from 11 to 15, right? So we're looking for this. We're looking for the value here, 10 to 11. And fortunately, we have the other two values, which is from 11 to 15 and from 10 to 15. So from 10 to 15, it's 10, and from 11 to 15, it's 4. So this would be the subtraction of the other two, right? The difference of other two. So from 10 to 15 minus from 11 to 15. So 10 minus 4 is 6. Do you agree?
That's not what we got, but that makes a lot more sense.
That was just to find that middle part, Kimberly.
Oh, that makes sense. Yep, my bad.
Right. Very good. So let me use a space here somewhere. Okay. Yeah. So since we have the value for 10 to 11 for the first function, we can replace it here. So for 10 to 11, we have 6. And for 10 to 11 for the other function, we already have this function already. It's 2, right? So it's 6 minus 2, although it looks really awkward. 6 minus 2, so the answer is 4. Any question from this? Let me show you the full screen if I can. Okay, yeah. Any question from this? Anyone, any question? Remember, you'll definitely have a question like this tomorrow. Okay, so if you have any doubts, I guess it is the best time to clarify that. Although it's pretty much algebra, it's pretty simple, but it could be tricky if you're somehow, for some reasons, if you're not getting it. Okay, don't hesitate if you have any doubts. All right, let's do the other two problems. So group 3, what's your answer for problem 3? G minus F for, or rather I would say from 11 to 15. Group 3. Matthew or Ada, if someone could answer.
I got -1.
-1, okay, let's try. So we have -1. Let's have that at the back of our head so that you can verify it. Okay, number 3. So it says from 11 to 15, we're looking for G minus F, right? Is it right? Yeah. So we already have the value for 11 to 15 for F. So that means we need the value for the other function. So this is technically 11 to 15 g of x minus 11 to 15 f of x, right? And as I said, we have the value for f. We know for 11 to 15, f is, what is that? 11 to 15, f is 4. So we can use that. But we need this value from 11 to 15 g. We don't have the value for this, or do we? I don't think so. Yeah, we don't have it. So we need to find it again, like the way we have done it for the other function in the previous problem. So we know from 10 to 15 g can be written as 10 to 11 of g plus 11 to 15 of g. Ah, gosh. G. Yeah. Okay. So we know this value. We know this value. We're looking for this one. So this would be 10 to 15 minus 10 to 11. So 10 to 15 is 5 and 10 to 11 is 2. 10 to 15 is 5, 10 to 11 is 2. So from 11 to 15, we have 3. Okay. And we, of course, we can replace these values. Oops. Why is that? Oh, here you go. So let me use the space. Okay. So from 11 to 15, g of x has given us 3. So your answer was absolutely right. It's indeed -1. Any question from this one? Anything? Any question? Although it's the method is exactly the same. We're just replacing some values, right? Okay, the next one. Group 4. I know you're all alone, but have you done it? Number 4. Have you done problem 4 for me?
I got it was 18.
18, okay. Let us check that. So from 10 to 11, I think we have found the value for f. What's that? 10 to 11. Yeah, the 10 to 11 for the first function gave us 6, right? We can use this since we have already done the calculation. So that means we can write it as 3 times 10 to 11 f of dx, f dx, and 10 to 11 was 6, so it is indeed 18. Very good. Any question from this one? Okay. So I guess that's it. You can expect questions of this 4 format. That means indefinite integral, definite integral, Riemann sum, and this type of properties. Okay, you can expect 4 types of questions. The type will be this 4. Okay, will not have any other types of questions. I'm spoon feeding you the question almost. So the types are here. Obviously, the values will get changed. Now, how confident you are for the next exam? Give me your honest opinion. If you have questions of these four format, these four types, which we have already seen today, do you think it's doable? It shouldn't be a problem. All of you, don't hesitate. You can send me a private message in the chat if you have doubts, or if you don't feel confident enough. And I really expect all of you to get 100% tomorrow, because as I said, the questions are here. These four types of question, only the values will get changed, nothing else. Okay. All right, so let me show you two more properties, and then we'll end our lovely little semester. So the last thing is the even and odd property, which you have already seen before, I guess, while we are doing derivatives, right? So can anyone tell me, can anyone remember what did we say when we first introduced this term odd function or even function? What can you remember?
Like when you do a graph, is that what you're talking about?
You can say the algebraic one, or you can say the graph, whichever you can remember.
Just like if it's odd, if it crosses the y-axis, it'll get, or crosses the origin, will get flipped over the y-axis, and if it's even, it'll stay.
Okay, yeah, that's very good. So can anyone tell me the algebraic format? Never mind, I think I should go for it because I don't have enough time, to be honest. So if you have a function, whatever it is, if you replace it with a negative x, okay? If you replace it with a negative x, and still in return, if you get the same function, then we call it as an even function. We call it even function. Let me give you a quick example. I think I have shown this before. So let's say x squared minus 3, okay? So if I replace x by a negative x, what do I get? I get x squared minus 3, which is exactly the same, which we had initially. So we call this is an even function, okay? But if we replace it by a negative x, and in return we get negative of what we had initially, then we call it odd function. And one good example would be, we can try this, x plus 1. If we replace it by a negative x, it will become, oh no, I think I should, let's try this one, yeah. So it will be, let's say this, negative x cubed, which is negative times x cubed, which is negative times f of x, because f of x was x cubed, right? So you can see by replacing it by a negative x, when we replace it by a negative x, we get negative times the initial function. And it is an example of odd function. So if we have even or odd functions, we can actually use a property, which is if you're integrating a function from negative a to a, and if your function is even, then instead you can write like this. Because if you remember, I did say that if you have an even function, for example, x squared, this is the graph of x squared. If you imagine a mirror here, this part on your right is actually the mirror image of what you have on your left. Can you see that? So if you're integrating it from negative a to a, instead what you can do, you can find the value from 0 to a and multiply it by 2 because it's the same. You can see this part and this part is the same. So that's what the property is telling you. Instead, you can integrate it from the mirror point, which is at 0, we assume, and multiply it by 2, right? And for the odd function, it's can you guess what might happen for the odd function? Anyone? If your function is odd, can you imagine what could happen?
It would just be the negative of that value.
Almost, but it's actually 0. Let me show you the algebraic approach. Why? So
Wait.
you can rewrite it as negative a to 0 and then 0 to a, right? I'm just subdividing this interval negative a to a into two parts, negative a to 0 and 0 to a, right?
Right.
For this part, f is negative. So you'll have negative of whatever you have here. And this part is exactly the same, but since you have a negative here and positive here, this will actually cancel out each other and give us 0. These two parts are equal, right? We know that because the property said if you replace it by a negative, it will become a negative f of x. So that means this part and this part will be same. Since this is a negative value of x, this will have a negative in front of it. Other than that, the value will be same. So this negative and positive part will cancel out each other and give us a 0. The graphical representation might look like this. So if you are integrating it from negative a to a, this one and this one behave same, right? But since this is negative values of x, you can see it's also giving you negative values of y because it's below x-axis. And I'm saying that this part and this part is equal. So you can clearly see this will cancel out each other and give us a 0, right? You can use these properties in some of the problems, maybe in near future, not in this semester. Okay, so